Welcome to the flight deck, focus learners. Strap in, because today we are flying at maximum altitude. We are talking about advanced, elite-level aerial combat tactics for tackling the absolute toughest, most unforgiving exam questions in your Cambridge Computer Science and IT syllabus. I am your strategist for this session, and today we are completely demystifying topic 19.1. We're looking deeply at grouping tools: group, ungroup, combine, join, add, subtract, and intersect. Now, this is specifically tailored for the Cambridge Information Technology 9626 syllabus, but listen up, because these master strategies, this examiner's lens we're applying, it applies across the board. Whether you're tackling 0417, 0478, 2210, or 9618, this is your blueprint. I want you to picture a standard past paper question. Imagine the exam hall. The clock is ticking down. The tension is thick enough to cut with a knife. On one side of the hall, we have a student. Let's call him Alex. Now, Alex has memorized the textbook. He overloads his paper with raw computer science facts, frantically dumping absolutely every piece of knowledge he has onto the page. He's writing definitions, drawing diagrams, but there is zero analytical depth. None. Then, on the other side of the hall, we have Sam. Sam is panicking. Sam is rushing against the clock, completely ignoring the command word requirements. Sam sees the word grouping and just starts writing about clicking buttons on a screen. Both of their answers, they are going to be bleeding red ink from the examiner's pen. They are leaving massive marks on the table. But today we are going to fix that. We're transforming those red marks into green check marks.
And you might be sitting there asking, why are we spending a whole explainer on just grouping tools? Well, let me give you a number that should absolutely make you sit up and pay attention. 15%. That's right, 15%. Mastering this single, incredibly specific topic, understanding how to properly deploy and, more importantly, articulate your knowledge of grouping tools accounts for approximately 15% of the total marks in Paper 2. Think about that for a second. That is a staggering amount of points wrapped up in one specific operational and theoretical domain. To put that into perspective, 15% is literally the difference between two entire grade boundaries. That's the difference between a B and an A star. It's massive. If you are aiming for that top tier, if you want to walk into that exam room with total confidence, you absolutely cannot afford to skip the analytical depth required here. You can't just know what the tools do, you have to know how to explain them perfectly.
Okay, let's dive into this. Here is our flight plan for today's masterclass. First up, we're going to explore the 15% edge so we really understand the real stakes of what we're dealing with. Second, we'll break down theory and analytical depth. This is where we look at exactly how examiners grade your reasoning. Third, we're uncovering what I call the method mark strategy, which is purely about flawless execution. Fourth, we are going to crack open the principal examiner's desk to reveal top examiner warnings so you can avoid the traps that catch everyone else. And finally, we will lock in the ultimate framework: deconstruct, solve, evaluate.
Let's move straight into our first major section, the 15% edge and truly understanding the stakes of the Cambridge exam.
We need to completely reframe how you look at topic 19.1. Listen to me closely. This is not just a software skill. Knowing how to click, group, or intersect in a graphics package or a relational database is only step one. It's the bare minimum. The real game, the exclusive insider strategy to capture those massive points we just talked about, is about proving to the examiner that you understand the underlying theoretical architecture of these tools. Let's look back at Alex and Sam for a minute. Alex knows where all the buttons are on the software interface, but when the exam question asks him to justify exactly why a subtract tool was used instead of an intersect tool to create a specific client logo, he totally freezes. He writes a superficial list of software steps. First I click this, then I click that. And guess what? The examiner gives him 0 marks for analytical depth. Because the biggest hurdle students face, straight from the examiner reports, is applying these concepts to unfamiliar contexts. The examiner is never, ever going to give you a standard, repetitive scenario you saw in your textbook. They're going to throw a massive curveball at you, a complex, multi-layered data modeling or graphic design problem that you've literally never seen before. Sam struggled because the second the context changed, Sam rushed and entirely missed the critical command words like evaluate or analyze. To beat this hurdle, you need advanced strategic tactics.
Let's shift our altitude and climb to Section 2, Theory and Analytical Depth. This is where we introduce the true academic benchmark.
To reach that high academic benchmark, top-tier candidates use something called the PEAL framework. That stands for point, evidence, explanation, link. It is the exact step-by-step blueprint used to structure every single high-scoring extended answer in Cambridge computer science. First, you decode the command word, then you make your specific point about the grouping tool, you provide evidence directly from the provided scenario, you write out an explanation of the technical mechanism, and finally, you link it all back to the core objective of the question. It is the literal difference between superficial breadth, just listing facts, and true analytical depth. Before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. All right, let's do a quick interactive check to test your analytical depth. Imagine a past paper question asking you to analyze the impact of joining two datasets. Answer A reads, joining combines two tables together so you can see all the data in one place. Answer B reads, applying a join operation establishes a relational link based on a primary key, which eliminates data redundancy and ensures referential integrity when generating the final client report. I'm giving you 3 seconds. Which one follows the Peel framework and gets the marks? If you said answer B, you are absolutely right. Answer A is just superficial breadth. It's exactly the kind of answer Alex writes. It's technically not wrong, but it gets no marks. Answer B is pure analytical depth. It explains the mechanism and links it to the outcome.
So the foundational rule here is that your entire theoretical architecture rests on incredibly precise definitions. You simply cannot write an analytical Peel paragraph if you are fuzzy on the core terminology. You need to know, without a shadow of a doubt, that the group tool logically binds individual elements together so they act as a single, unified entity, but crucially, without altering their individual properties. Ungroup shatters that binding, reverting them back to independent elements. Combine, or join, merges datasets or vector shapes entirely, often creating a single continuous path or a flat data structure. Add or subtract deals strictly with Boolean operations. You are literally adding overlapping areas together to make a new shape or punching out one shape from another like a cookie cutter. And intersect, that retains only the specific overlapping regions of multiple elements while discarding the rest. When you internalize these definitions, we start watching the red pen marks on Alex's paper physically transform into green check marks. Just by deploying these precise, technical definitions within that Peel framework, you are already ahead of 80% of the candidates.
But we aren't stopping there. Let's push the throttle even further. The principal examiner reports give us an absolute massive cheat code here, and you need to pay attention to this. Candidates who connect these grouping tools to other syllabus areas score significantly higher. We're talking top of the class. You need to establish causal relationships and make cross-topic connections. Don't just tell the examiner you use the intersect tool. That's boring. Explain the cause and effect. You write something like, by intersecting the two complex vector shapes rather than grouping them, the overall file size was drastically optimized, which directly impacts the cross-topic requirement of fast web load times for the client's homepage. Boom. Drop the mic. You just connected topic 19.1 to network performance, bandwidth, and web optimization. The examiner reads that and instantly knows you operate on a completely different level. That is how you fly at maximum altitude.
Now we're entering Section 3, the method mark strategy. We've nailed the theory. Now this is all about flawless execution and process on the actual exam paper.
Like I said, we've talked about the theory in your head. Now we have to talk about what actually goes down on the physical paper. In Cambridge IT, and especially in the grueling paper too, the journey is just as important as the final destination. You can get the final software output completely right, perfectly matching the brief. But if you don't document your process using strict conventions, you will hemorrhage marks. Burn this exact phrase into your memory right now. Marks are awarded for process. The method mark strategy dictates that the precise, methodical way you present your information is exactly what gets graded. Remember our student Sam? When Sam rushed the exam, Sam just wrote down the final answer. Sam completely skipped documenting the intermediate ungroup and subtract steps that got him there. So even though his final image was right, the examiner couldn't award any of the crucial method marks. You have to actively prove your technical methodology, step by methodical step. Stop scrolling. Subscribe to our YouTube channel Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to at acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
And that methodology, it follows a set of strict non-negotiable conventions. You need proper headings to organize your thoughts so the examiner can easily navigate your answer. You must use correct terminology. You write intersect instead of cut out, or join instead of smush together. You have to use appropriate formats, ensuring your outputs actually meet the highly specific context of the client's brief. And finally, clear annotation. You have to show the examiner exactly what you did and why you did it, leaving absolutely zero guesswork.
Let's put this process into action. We are entering the interactive workshop phase of this explainer. I'm going to walk you through the exact 5-step chronological workflow that top students use. Step 1, deconstruct the question. Step 2, extract relevant data. Step 3, select your analytical framework. Step 4, execute with clear notation. Step 5, present with correct terminology. Challenge 1 starts now. I want you to imagine a massively complex Cambridge data source sitting on your screen right now. It's a huge table requiring complex grouping and relational joining. You have a 60-second visual countdown timer ticking away in your head. Go. You scan the data. What is the core trend? Your brain should immediately be deconstructing what is the command word here. If the command word is evaluate the use of grouping tools, you don't panic. You extract the data, you mentally select the Peel framework, and you prepare to execute. This 5-step workflow is the ultimate blueprint. It systematically dismantles any exam question, no matter how weird the context is.
All right, take a breath. Now we pivot to Section 4, Top Examiner Warnings and the absolute critical pitfalls you need to avoid.
We are jumping straight into Challenge 2, Find the Flaw. I am going to tell you the specific, frustratingly common mistakes that cost candidates easy points, straight from the principal examiner's own desk. Here is a massive, flashing red flag. Examiner alert. Candidates consistently confuse key terminology. They use combine when they actually mean group. They use subtract when they really mean intersect. It drives examiners crazy. So what's the examiner's advice? Always define your terms first before using them in extended responses. If you start your paragraph by briefly, sharply defining the tool, you anchor your entire answer in correct theory. So here is our flawed paragraph for Challenge 2. Listen closely and find the flaw. To fix the client's logo, I grouped the two overlapping shapes to remove the middle part. Did you spot it? I'll give you a second. You absolutely cannot use the group tool to remove an overlapping part. That physically makes no sense. Removing an overlapping part requires the subtract or intersect tool, depending on the exact desired outcome. Writing that one sentence, just rushing through your terminology like our friend Sam, just lost you 3 easy marks.
And it gets worse. Here are the top 3 student mistakes pulled directly from years of examiner reports. Number 1, forgetting to include proper format. Number 2, failing to check format and presentation before moving on. Number 3, providing generic answers that are not specific to the given context. This brings us to Challenge 3, speed writing. You have a 30-second timer on the clock to mentally write one perfect Peel paragraph. Your command word is justify. Your context is a retail database report. Your tool is join. Go. TikTok. Okay, here's your perfect answer. Point. Joining tables creates a unified relational report. Evidence. Connecting Table A for products and Table B for sales via the product ID primary key. Explanation. This eliminates data redundancy compared to using flat, unjoined files. Link. Therefore meeting the retail client's need for an efficient, real-time database. Do you see how powerful that is? That is how you avoid these top 3 mistakes. You stay relentlessly specific to the context.
Let's bring all of this together in our final section, Section 5, Deconstruct, Solve, Evaluate. This is the ultimate framework.
This is the evaluation framework that strictly separates the merely good candidates from the truly great top-tier ones. At the center of all this is something called evaluative thinking. But what does that actually mean? Evaluative thinking means you actively question assumptions, you consider alternative perspectives, and you ruthlessly justify your decisions with hard evidence. Let's say the exam asks you to evaluate the use of an Ungroup tool on a highly complex architectural diagram. You don't just say what the tool does. Any average student can do that. You identify the hidden limitations. You write, while ungrouping allows for the granular editing of individual architectural elements, a major limitation is the high risk of accidentally misaligning structural components, which directly compromises the scale and integrity of the technical drawing. Look at what you just did. You evaluated the quality of the action. You identified a real-world limitation, and you provided an expert perspective. That is how you get maximum marks.
This brings us to the final problem-solving loop, the complete computer science answering system. It relies on 3 rules that guarantee top marks. Number 1, command word decoding. Number 2, Peel framework application. And number 3, a time management matrix. You apply those rules through this 5-step loop on screen. Step 1, identify given information. Step 2, break it into logical steps. Step 3, solve systematically. Step 4, check for reasonableness. Ask yourself, does this output actually make sense? Step 5. Make justified recommendations. If you apply this systematic loop to topic 19.1, or any topic for that matter, you become an absolute, unstoppable force in Paper 2. You will never ever look in an unfamiliar exam context and freeze like Alex, or panic like Sam again.
As we prepare to land, I want to leave you with this final, highly provocative question to chew on. Are your answers specifically tailored to the context of the exam paper, or are you just blindly repeating memorized routines you read in a textbook? The method mark strategy demands adaptation. Alex and Sam learned this the hard way, but now you have the ultimate blueprint. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder: subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here. Keep flying at maximum altitude, and I will see you in the next explainer.